Welcome everybody to Algebra 1, Section 3.2, Multi-Step Inequalities. So here we're going to be solving, graphing, and writing the solution to each inequality in interval notation. And this is essentially very similar to 3.1 where we did two-step inequalities and one-step inequalities, where the only real differences between this and solving equations are the fact that there's an inequality symbol, and that if we flip the entire inequality around, such as x is less than 3 to 3 is greater than x, that we have to switch the inequality symbol as well if we switch the x and 3 around, for example, the sides of the inequality. And then the other key difference is that from equations is that if we multiply or divide both sides by a negative number, we have to flip our inequality symbol. And so other than that, really going to be the same stuff as solving multi-step equations, where we focus on distributing if we need to, and then we focus on pardon me, doing SADMEP from there, or solving just like we would a two-step equation. Then we're going to graph like we did last time and do interval notation like we did last time as well in 3.1. So here, starting with number 1, we need to distribute this 4. So I distribute the 4, and I get 4 times x is 4x, 4 times 3 is 12, and I have this being greater than negative 24. Now I'm going to go ahead and subtract the 12 because my variable is being multiplied and added. I undo the addition first, and I get 4x is greater than negative 36. Now I have my variables on one side and my numbers on the other, so I'm going to go ahead and divide to undo the multiplication of 4. And I get x is greater than negative 9. That's my answer there. And I do not flip the inequality because even though the answer is negative and 36 was negative, the number I divided by was positive. So now we go ahead and graph here. I'm going to put that number negative 9 in the middle, a number bigger than it on the right, such as negative 8, and a number smaller than it on the left, such as negative 10. This is an open circle. Once again, an open circle is when you have less than or greater than, whereas a closed circle, a filled-in circle, would be for less than or equal to or greater than or equal to. And then the arrow would be going to the right because those are the numbers greater than negative 9. Remember also the little trick that when the variable's on the left of the inequality symbol, this inequality symbol can match the arrow, or matches the arrow directionally. The interval notation here is that one with commas and parentheses or brackets, and so it's the lower number, comma, bigger number, the left part, comma, right part, and so it goes negative 9 is the farthest left it goes, comma, infinity is the farthest right it goes because it goes forever. Infinity and negative infinity are always parentheses because they're concepts you can't actually reach rather than a number. And then when it's an open circle, when it's not or equal to for inequality, it's a parenthesis because that's saying negative 9 is not part of the answer, but anything after or greater than negative 9 here is. Moving on to number 2. Number 2, I have to distribute a 3. However, this 3 is not just 3, it's negative 3. Make sure to take that negative with the 3. And to do that, I like to make this plus a negative. And so I keep the x the same. I now multiply negative 3 times x to get negative 3x. And negative 3 times 2 to get negative 6. And I have this greater than 4. Next, I'm going to combine like terms. So I have x minus 3x is negative 2x. Minus 6 is greater than 4. Now you could have done this next step instead of doing x minus 3x here and switch the order of the steps around. So I'm going to go ahead and add 6 now to undo the subtraction. Once again, if you would have added 6 before combining x and negative 3x, that's fine as well. Some people might do that. I prefer combining like terms first to make these equations all follow a more uniform pattern. Now as I divide both sides by negative 2, I have x, I have negative 5, but I must flip my inequality since I divided both sides by a negative. X is less than negative 5 is my answer. So now I'm going to go ahead and graph this, where I put negative 5 in the middle, negative 4 on the right, negative 6 on the left. Once again, a bigger number on the right, smaller number on the left. It's an open circle going to the left, and the interval notation would be negative infinity is how far left it goes, forever left, forever negative, comma, negative 5, and then both are parentheses here. Number 3 here, we once again have to distribute. This time we're distributing a negative 2, so I'm going to make this plus a negative 2. I bring down the 7x as it's not changing yet. Negative 2 times x is negative 2x, and negative 2 times negative 4 is a positive 8. Be careful with these two negatives, that we make sure that's positive. Then that's less than or equal to negative 2. I combine like terms here, so 7x minus 2x is 5x. I'm going to get 5x plus 8 is less than or equal to negative 2. Let me just kind of emphasize this x since that wrote pretty faintly. Then I'm going to subtract my 8 to undo the addition, and I get 5x is less than or equal to negative 10. Dividing both sides by 5 yields or results in x being less than or equal to negative 2 as my answer. And so now I'm going to go ahead and graph this over here, putting negative 2 in the middle, a number bigger on the right, a number smaller on the left. This will be a closed circle since it's or equal to, and my arrow is going to be going left since it's less than or equal to. My interval notation is negative infinity, comma, negative 2, with negative infinity a parenthesis, and negative 2 getting a bracket since it's the or equal to, as well as a filled-in circle. Moving on to number 4 here. Negative 8 times the quantity of x minus 1 minus x is less than or equal to negative 28. I distribute my negative 8, and I have negative 8x plus 8 minus x is less than or equal to negative 28. And a point I probably should have brought up a little bit prior, but I'll bring up now, is that even though we multiplied by a negative 8 to these two things right here, to get the results of negative 8x plus 8, we don't flip our inequality symbol because we didn't multiply or divide both sides by that negative. We only distributed to one part of the problem. I combine like terms, negative 8x and negative x give me negative 9x plus 8 is less than or equal to negative 28. Then I subtract 8 from each side, and I get my 8 didn't right there for whatever reason. I get negative 9x is less than or equal to negative 36. Then dividing by negative 9 gives me x is greater than or equal to 4, flipping my inequality since I divided both sides by a negative number. I'm then going to go ahead and graph this with 4 being in the middle, 5 on the right, 3 on the left, and it'll be a closed circle going to the right. Then my interval notation would be 4 comma infinity with 4 on the left, infinity on the right because it's least to greatest. Also matches the order in the graph, 4 and infinity left and right. 4 getting a bracket since it's or equal to as well as a closed circle, with infinity being the parenthesis. Last one on this page, number 5. Number 5 here we don't have any distributing to worry about, but we do have two variables, one on each side, and so now we need to move the variables all to one side. So we might develop some preferences here. So before, when we solved equations, I stated that my preference is always to move the smaller variable. That way we will always have a positive variable, and we like dealing with positive numbers. However, sometimes we might have to choose in a problem between moving the smaller variable, in this case negative 2x, and having variables on the left. Because when we graph the inequality, it's easier to have the variables on the left, and that's how I personally prefer it as well. And so I still personally like to keep my variables positive, and then I'll switch back to the inequality at the end if I need, which we'll see at some point in these notes. Yeah, we'll see on problem 6 there. I was just double checking my note packet that we'd see it. But once again, you might develop your own preference, and that's perfectly fine. So personally, I'm going to move my smaller variable, which is negative 2x. How I move it from one side to the other is I do the opposite by adding 2x. And I get 8x plus 1 is less than 9. Now that I have my variables on one side, I want my numbers on the other side. So I subtract 1 to undo that. And I get 8x is less than 8. Now that my variables and numbers are on opposite sides, I go ahead and divide to undo the multiplication of 8. And I get x is less than 1 as my answer. I go to graph this, and I get 1 in the middle, 2 on the right, 0 on the left, open circle going to the left. And my interval notation is negative infinity, comma 1 with a parenthesis on each. Moving on to example 6 here. We have 2x minus 1 is less than or equal to 5x plus 20. So if I move my smaller variable here, we'll be moving our variables to the right, which once again isn't wrong, but some of us might prefer having our variables on the left, which then creates a negative as we subtract 5x. and 2x minus 5x would give us negative 3x. So personally, I prefer moving the smaller variable still, so that's what I'm going to do, but you could do whichever you so choose. So I'm going to subtract 2x. Even though this minus is here, that minus is with the 1, the 2x is still positive. And so we have 2x minus 2x is 0. I get negative 1 is less than or equal to 3x plus 20. Then I will subtract 20 to move my numbers to the side opposite my variables. So now I have my variables on the right, numbers on the left. As long as they're opposites, that's what I care about. That's less than or equal to 3x. Then I'm going to go ahead and divide by 3 to undo the multiplication of 3. And I get negative 7 is less than or equal to x. Now, this is the answer. I personally prefer to have my variable on the left. That helps me with my graphing, and so I like to do that to make my life a little bit easier in that regard. So I just rewrite the whole thing, but because I flipped the sides of my inequality, I need to flip the inequality sign or symbol itself. So now it's x is greater than or equal to negative 7. Once again, you could box the light blue. I just prefer the red personally, so that's what I do. So negative 7 in the middle, negative 6 on the right, negative 8 on the left. A closed circle going to the right. And the interval notation is negative 7 comma infinity, with negative 7 being a bracket. Moving on to number 7 here. We have variables on each side, and we must distribute. However, the only thing we distribute here is a negative, so pretend this is a negative 1 and multiply it through, or what I like to do is just change this to a plus sign and change every sign inside the parenthesis to the opposites. So the positive 2x became negative, and the negative 7 became positive. Now I'm going to go and combine like terms on this side. 3 and 7 give me 10. So I have negative 2x plus 10 is less than or equal to 34 minus 6x. Now, my smaller variable, which is what I like to move again, is to add 6x to move my smaller variable over the negative 6x. And I get 4x plus 10 is less than or equal to 34. Now, since all my variables are on the left, I need to get all my numbers on the right, opposite the variables. And so I'm subtracting 10, and I get 4x is less than or equal to 24. Now, if I divide both sides by 4, I end up getting x is less than or equal to 6. So I'm going to go ahead and graph that, putting my numbers in the appropriate places. A closed circle going to the left, and the interval notation is negative infinity, comma 6, with 6 getting a bracket. Moving on here to number 8. Number 8, once again, I need to distribute, so I distribute negative 3. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Minus the 3x, so that's still just hanging out, chilling, is less than 2x plus 18. So now I'm going to go ahead and combine my negative 3x's, and I get negative 6x minus 6 is less than 2x plus 18. I'm going to move my smaller variable, which is negative 6x, which moves them to the right. If you prefer to have them on your left, regardless of the signs, then you would want to subtract 2x instead. But as it is, I have negative 6 is less than 8x plus 18. I'm going to go ahead and subtract 18 from both sides, move my numbers to the opposite side of my variables. I have negative 24 is less than 8x. If you had your 8x on the left, it'd be a negative 8x, and if you have your 24 on the right, it'd be a positive 24. The signs just switch. And so we divide both sides by 8. And I get negative 3 is less than x. If I now flip this around, which is how I prefer it, I will do x is greater than negative 3. Once again, the light blue is not wrong. I just prefer it in the orange myself. So I go and graph x is greater than negative 3 by putting negative 3 in the middle, negative 2 on the right, negative 4 on the left, an open circle going to the right. Do the trick. And the interval notation is negative 3 comma infinity, with both being parentheses. Number 9 here, I have to distribute a negative 3. On the right side, I have to distribute a negative. So on the left side, this 5x is hanging out chilling, and the 3 becomes negative, distributes in, so the negative 3 distributes in, and I get negative 3x minus 18 is greater than or equal to 8. Change the signs here. And I'm actually going to go and just combine like terms while I'm at it on that side, and get 8 and a positive 7 give me 15 minus x. Continuing to combine like terms on the left side, I get 5x minus 3x is 2x minus 18 is greater than or equal to 15 minus x. So now I'm going to go ahead and add x to each side to move my x's together. I get 3x minus 18 is greater than or equal to 15. Since all my variables are on one side, I want my numbers on the opposite side, so I add 18 to move my variables to the opposite side of my numbers to the opposite side of the variables. My apologies on that. 3x is greater than or equal to 33. So if I go ahead and divide both sides by 3, I get x is greater than or equal to 11 as my answer. And so now I go ahead and graph that. 11 in the middle, a number bigger on the right, a number smaller on the left, and this is a closed circle going to the right. And the interval notation reflects that, as it's 11 comma infinity, with 11 having a bracket. And last but not least for today, number 10, I distribute this negative here to start, so I change the signs and everything here. And then I'm going to go and combine like terms, and I get negative 3x and negative 2x give me negative 5x minus 3, or plus a negative 3, it's the same thing, is greater than, I distribute the negative 4, and I get negative 4x plus 8, as I do negative times a negative, minus 2. On the left side there, on the right side, I still must combine like terms, so I'm just going to rewrite my left side here as I combine like terms on my right. And I combine the 8 and the negative 2, and I get negative 4x plus 6. Then I will go ahead and move my smaller variable, which is the negative 5x. Once again, it would not be wrong to move the 4x, the negative 4x to the left by adding it. And I get negative 3 is greater than x plus 6. Subtracting 6, I get negative 9 is less than x. If I just flip that around, I now have the answer. X is less than negative 9. Once again, the purple is perfectly fine. I just prefer the blue. I go ahead and graph that. Negative 9 in the middle, a number bigger on the right, a number smaller on the left. An open circle going to the left does the trick for the graph. And the interval notation would be negative infinity, comma, negative 9, with both being in parentheses. And that wraps up Algebra 1, Section 3.2.